Yes, in the last class, we have discussed about electric motor, Fleming's left-hand rule. Now, we are going to discuss another topic associated with the magnetic effect of electric current, and this is electromagnetic induction. In this topic, there will be subtopics like electromagnetic induction, Faraday's law of electromagnetic induction, and generator and alternating current and power production, self-induction. Self-induction is not to be discussed here, and power transmission and field induction. So first of all, through an activities, let us try to understand what is electromagnetic induction. First of all, you see here, this is a this was discovered by Faraday and Henry in 1831. You can do such activities even at home. When you plunge a magnet into a coil of wire, a voltage is induced in the coil and a current is produced. You see here, no battery is there, only this is the galvanometer and this is the coil, which is made up of insulated copper wire and a bar magnet. So just you need to keep moving bar magnet back and forth inside the coil, then you will see that the pointer or needle of galvanometer deflects, indicating that there is current in the circuit or in the coil. So from where this current comes from, or from where voltage is supplied, no battery is there, no generator is there connected in the given circuit, still there is deflection in the galvanometer's pointer. So what could be the reason behind it? If you replace the galvanometer and connect another electrical gadget that works on very small supply of current, then you will see that even that gadget will work with this amount of current. It means you can say that you will connect LED bulb here for indicator, and you will see that while magnet is moving back and forth inside the coil, the LED bulb will glow, indicating that there is a current in the circuit. But question is that from where this current comes? There is no supplier of current in the circuit. There is no connection of battery or generator or shell with the circuit. Still, we get current. From where this current comes from? So you will see that energy is spent in moving the bar magnet back and forth is converted into electrical energy. You can say this energy is mechanical energy. So here just reverse principle works, that in the previous case you have seen that when we supply electrical energy to electric motor converts electrical energy into mechanical energy. Now we take just reverse activities. We don't supply electrical current, but we supply mechanical energy. You will see that here mechanical energy converted into electrical. So mechanical energy is nothing but kinetic energy or sum of kinetic energy and potential energy. You see here a bar magnet with the hand is continuously keeps on moving back and forth. ए शाश्वत जाओ देखो सर आए हैं back and forth. That's why this mechanical energy in terms of kinetic energy that is supplied by muscular force of your hand is converted into electrical energy. Now let us move in another activity that would indicates that direction of current and magnitude amount of current to be produced depends on various factors. So here you will see that electromagnetic induction you see here. This is the conducting wire in the form of a rectangular loop, and one end of the wire is connected with the one terminal of galvanometer and other connected with the other terminal of the galvanometer. And here you shaped magnet. This magnet, when is at rest, no deflection will be observed here. But when this magnet keeps on moving, either sideways or up and down, you will see that pointer of galvanometer would deflect. So deflection in the galvanometer's pointer depends on movement of magnets nearby the conductor. Now here you see we keep magnet at rest. Here conductor was at rest and magnet was moving back and forth. Now we reverse the conditions. We fix the magnet and move the conductor. Then we will see that again deflection is there. So voltage is induced in the wire loop whether the magnetic field moves or magnet itself moves past the wire or the wire moves through the magnetic field. That is relative motion of magnetic field or magnet or conductor with respect to one another are responsible for producing induced current in the circuit. So whenever there is a relative motion between conductors and magnets, current will get induced in the conductor. That current can be used for various purposes. That happens in the electric generator. Okay, now another activity you can see here, electromagnetic induction. You see here, this is a coil and a galvanometer here. When you move, pointer will deflect. When magnet moves inside, pointer will deflect this side, that is anti-clockwise. When magnet moves outwards, then pointer will deflect in clockwise. You see here, while it is taking out of the coil, then it will deflect from this position to neutral position. And again you see that when the magnet is coming out as a whole from the coil, this deflection will be in this direction. So when magnet is plunged into the coil with twice as many loops as another, so twice as much voltage is induced. It means if there is 2 turns, if there is 4 turns and here is 6 turns, what will happen? Amount of deflection will get increased. You see here, only 2 turns is there, so less deflection will be there. Here 4 turns in this coil, so deflection will be twice of this one. If with the same speed magnet is moved inside the coil, deflection will be doubled due to the number of turns double in this coil. And here deflection will be 3 times of this one, because here is 6 turns there in the coil. Now, when magnet is plunged into the coil with twice as many loops as another, twice as much voltage is induced. If the magnet is plunged into the coil with the 3 times as many loops, so 3 times as much voltage is induced. That you have got it well. Now, we have learned that if you want to increase the amount of induced voltage to be produced, you have to increase number of turns in the coil. If magnetic field and magnet is same and the speed of movement is same, still you want to have larger induced EMF or voltage, then you must increase number of turns. Here you see, it is more difficult to push the magnet into the coil with many loops. Here number of turns are so many. Here it will be difficult to push or take out the magnet, because as you push, the coil opposes the movement of magnet towards it. This is because the induced voltage makes currents in the coil, which makes an electromagnet. As soon as you move the magnet inside the coil, current gets induced in the coil. Now current is there in the coil, so you know well that current carrying coil or current carrying solenoid act as electromagnet. So this electromagnet will oppose the movement of permanent magnet that you move into the coil because of repulsion, which repels the magnet in your hand. So more loop means more voltage is there, which means we do more work to induce it. If you increase the number of loops, number of turns in the coil, then you have to do more effort to move the magnet inside that coil, because of coil repel the magnet. Now come to the point. Looking over all the activities in the previous section, if you summarize all of them together, then you will come to know law of electromagnetic induction that was given by Faraday. According to this law, the induced voltage in the coil is directly proportional to the number of loops or turns multiplied by the rate at which magnetic field changing within these coils or loops. You can bifurcate this law. In one, you can say that amount of voltage produced in the coil depends on two factors. First one is, it depends on number of loops, that is, it is directly proportional to number of turns of the coil. Next, it is directly proportional to a rate at which magnetic field is changing within the coil. So when you combine these two factors together, you can say that according to Faraday's law, the induced voltage in the coil is directly proportional to number of loops multiplied by the rate at which the magnetic field changes within these coils. An amount of current produced by electromagnetic induction depends on three factors. First one is resistance of the coil, circuit that it connected, and induced voltage in the coil. More is the induced voltage in the coil, more will be current produced in the coil. So voltage is induced in the wire by changing the magnetic field passing through the loop of the wire. You can see the example of here. This is a musical instrument. You would know the name of this instrument. This instrument's working of this instrument is based on electromagnetic induction. Okay, so now try to understand. Voltage is induced in the wire by changing the magnetic field passing through the loop of the wire, and this can be done by moving the loop near the magnet, or moving a magnet near the loop, or changing the current in the nearby loop. By three factors, you can induce voltage in the wire. So now come to the point, application of Faraday's law of electromagnetic induction. You see, activation of traffic lights by a car moving over underground coils of wire. There is an underground coil. So as car moves and electric voltage, induced voltage get induced in the coil, and that causes traffic light to be activated. Second one is triggering security system, that when you enters at a public place, which is a very sensitive place, and if unauthorized person enters through the gate, then it will check them automatically, triggering security system at the airport. You as you see that at airport or at railway stations, by altering magnetic field in the coil as one walks through the gate. Gate is fitted with a rectangular coil, and when you enter through that coil, you just change the magnetic field, and hence there is indicators or alarm that would start activated. Now, scanning magnetic strips on back of credit cards, you say ATM cards or credit card, all these cards work on the principle of electromagnetic induction. When you insert the card has magnetic chip there. So due to movement of the card in the strip, a certain amount of electric signal produced, and that signal is calculated digitally and then recognize that it is you. Recording of sound on a tape. This is also electromagnetic induction. Electronic devices in computer hard drive, that you see the memory of computer's hard drive is terabytes or TB. iPods, all these are based on electromagnetic induction. Now, so far we have learned about electromagnetic induction. Now we apply the electromagnetic induction to generate electrical energy. Electrical energy, a generator is a machine that converts mechanical energy into electrical energy. That is opposite of a motor. So in motor, you first supply electrical energy, and then motor converts this energy into mechanical energy in terms of a spinning or rotation. On the other hand, here you supply mechanical energy. In turns, you will get electrical energy. So, electric generator is a device or machine that converts mechanical energy into electrical energy via coil motion, because magnet is kept fixed, coil allowed to be moving continuously. So, motion of coil consists of electrical energy that could be supplied in any form. Even that could be supplied by muscular force, that could be supplied by chemical energy in terms of petrol and diesel. It is so electric generator produces alternating voltage and current. Even it can produce direct voltage or current. So alternating voltage or current when produced, then generator is called AC generator. If direct current is produced, then it is called DC generator. Difference is there only that in AC generator there are two complete commutating ring, but in DC generator there are only one a splitted ring, a single ring are splitted. Now try to understand here. This is a magnet. One of the end of this can be treated as pole, north pole and south pole, and in between this a coil is there, current carrying coil, no current carrying coil. There is no supply of current but supply of mechanical energy from external source. This coil is free to rotate about this axis, that is imaginary line given there. Now question is that you need energy to rotate it. That energy is supplied in any form. Here it is supplied manually by your hand. You rotate this coil by applying a force here, then it starts rotating, and you will see that due to rotation this bulb starts glowing, indicating that due to motion of this coil inside the magnetic field, current get induced in the coil. So you see here the coil will have various position. You see here when it rotates we can take four position: when it is flat, when it is vertical. So now try to understand. In this case large number of field line will cross through this coil, so current induced in the coil will be maximum. In this case minimum field lines or no field lines process through this coil, so no current passes through in this situation. And in this situation current passes through the coil but in opposite direction and becomes maximum here, and again increases and becomes zero at this position, and again maximum at this position. So this graphical variation of current with the rotation of the coil is called alternating current or voltage, because alternately voltage becomes positive and negative. For half cycle it is positive, for next half cycle it is negative. So if you starts from here, so this cycle is negative and this cycle becomes positive. So alternately it becomes positive and negative as coil rotated. So alternating voltage is produced by the generator, and this is called AC generator. So using this concept you can produce power, electrical power, using various sources of energy available and that can be converted into electrical energy. So using concept of Faraday and Henry's discovery of electromagnetic induction, Nikola Tesla was a scientist, and Washing George Westinghouse showed that electricity could be generated in sufficient quantity to light city. That means in order to light the cities, we can generate electricity with the help of energy contained by the moving air, that is wind, and it's called uh, power generated from wind. So you see here a steam. If you supply a steam here to this rotor will start rotating, and in turns the coil over this will also start rotating, and this magnet is kept fixed here. So due to rotation of this coil, current will be generated in this, and bulb will start. So even at home you can generate a small sample of generator. Now power production using Faraday, I have already discussed that. This is a small sample that you can say this is a model of power production at power station like thermal power station and hydropower station and nuclear power stations and wind. Everything setup will remain same. The same setup can be used to produce electricity with the help of various sources of energy supply. Here, steam energy is supplied. In thermal power plants, heat is generated to produce steam, and then that steam is used to rotate the turbine, and hence electricity is produced. Now, what happens in hydropower plants? In hydropower plants, water is allowed to fall from waterfall. A falling water has kinetic energy when it falls onto the turbine, blades of turbine. Turbine starts rotating. And this rotating turbine produces electrical energy. So same setup, only change is that the supply of energy gets changed. In hydropower plants, potential energy of water, which is kept at high by making a dam and then allowed to move this water from high potential. So this water get converted into kinetic energy when uh, falls onto the turbine's blade. In turns, blade turbine starts rotating and produce electrical energy. Now, magneto-hydrodynamic generator MHD. This eliminates the turbine and a spinning armature altogether. A plasma of electrons and positive ions expands through a nozzle and moves at supersonic speed through a magnetic field. Even in that case, power is produced. So here you can see that motion of charges through the magnetic field gives rise to voltage and flow the current as per Faraday's law. So here, and same electromagnetic induction can be used in case of transformer. This is application of Faraday's law. You would have seen the transformer near about your house. Okay. So you would have seen transformer near about your house, and you need to know how this transformer works. A simple transformer consists of two coils over the same iron core. As you see here, there is two coils. This is one coil and this is another coil. But these coils and these coils are not in being contact with each other. There is no electrical contact between the two coils because coil is insulated. Although it is wrapped over the iron core, but this is insulated coil, so it has no electrical contact with one another and even not with the iron core. So when there is a change in current in this coil, you will see that bulb starts glowing in this coil. Although this coil is not in actual contact with this coil, then how bulb get glow without any supply of electrical energy in terms of battery or generator? You must see that as you change the current in this coil, magnetic field changes continuously, and that's in turns the electromagnetic field here get changes because electromagnetic field is coupled with this one. If you change the magnetic field here, this change will appear here, and that's why this bulb starts glowing. This is the simple uh, structure of transformer that works. A transformer consists of two sets of coil. First one is called primary coil and second one is called secondary coil. So primary coil, we say input coils. So we supply high voltage current into the primary coil, and we get low voltage current in the secondary coil because uh, power supplied from the power station is at high voltage and low current because this power is supplied to the distant place. That's why power must consist of high voltage and low current. Low current uh, means that less amount of energy will be dissipated in terms of heat because of it. As length of the coil and length of the wire increases, resistance would increase. Output coil of the wire is a secondary coil connected to the external circuit. Okay. So, as in a simple way, a transformer consists of two coils called primary and secondary coil. Primary coil is said to be input coil and secondary coil is said to be output coil. That is, in primary coil, we feed electric current at high voltage, and in secondary coil we get electric current at low voltage. So even reverse is possible. So therefore there will be two types of transformer. So let us understand. First one is a step up transformer. Here step up transformers are those which produces greater voltage in the secondary coil than supplied by the primary coil. You can understand that we supply less voltage in the primary coil, but we get high voltage in the secondary coil. So such transformer is called step up transformer. So, and this is done by making number of turns in the secondary coil higher than that of the primary coil. As we have already discussed that as we increase the number of turns in the coil, amount of induced voltage will get increased. That's why number of turns in the primary coil is less than that of the number of turns in the secondary coil. Then such transformer will be a step up transformer. Now, in case of a step down transformer, it produces a small voltage in secondary coil, then the voltage supplied in the primary coil. So in our house or for the domestic power supply, a step down transformer is used because 11,000 volt of supply is supply into the input terminal, or that is into the primary coil, and we get 440 volts or 220 volt supply at the output terminal. In your house, 220 volt supply is there that you take from the transformer, although transformer gives 440 volts, although input power is given as 11,000 volt, but output power is 440 volts or even less than that one. So that's why it is a step down transformer. So you see here, this is the simple structure. This is iron, solid iron structure in the form of plates. So many iron plates are placed over one another with the separating insulating plane or mica, and over this side number of turns in the coil is 2, 1 and 2, and here number of turns in the coil is only 1. So such types of transformer will be a step up transformer because we give 1 volt input and we get 2 volt output. So less voltage is supplied into the input terminal and high voltage is obtained at the output terminal. So this is the step up transformer. In case of step down transformer, the case will be reversed. If you supply 2 volts at the input, you will get 1 volt at the output or even lesser than that. So transformer relationship, primary voltage divided by number of turns in the primary coil equal to secondary voltage divided by number of turns in the secondary coil. And using this relation, you can correlate this one. So transformer transfers energy from one coil to another coil. That's why it is called transformer. And you know well that transformer is based on electromagnetic induction principle. Rate of energy transfer is power. That is, rate of energy transferred from one coil to another coil is called power of the transformer. Power input primary must be either equal or greater than output power output of the secondary, or neglecting a small heat losses, voltage into current in the primary coil, because you know that voltage into current is nothing but power, equal to voltage into current into secondary coil. That is, if there is no loss of power in the form of heat and sound, then power at the input coil, that is the primary coil, must be equal to power at the secondary coil. But in real transformer, there is a loss of power in the form of sound, humming transformer, and heat produced. So a little bit power is wasted. Uh, Hello. Now, so far we have discussed that power, how power is produced and power is supplied. There is another concept now. After producing power, now you need to transmit the power from power station to consumer point, and that could be done through the wire, and this is called power transmission. Almost all electrical energy sold today is in the form of AC. Because of this, AC is easier to supply to the distant place with the help of wire, to transfer, to transmit to the distant place with the help of wire in comparison to DC, because there is less power loss in case of AC in comparison to DC. That's why AC is preferred to supply to the distant place in comparison to DC. Large current in a wire produce heat and energy losses. So power is transmitted a great distance at high voltage and low current. You must keep in mind, while supplying power from power station to the consumer point to the distant place or to the distant city, this is done at high voltage and low current. That is, at the power station, before supplying, voltage is kept high and current is kept low, such that there would be less dissipation of power while transmitting or while transmission to the distant place. Now, as for example, here you can see power is generated at 25,000 volt or less and is up, stepped up near the power station to as much as 7,50,000 volt for long distance transmission. Do you know why? Because power station produce the power only at 25,000 volt or even less, but before supplying it, it is converted into 7,50,000 volt, because it is supplied to distant place. So if it is at high voltage and low current, then there will be less dissipation, and this is done by a step up transformer. A step up transformer meet the purpose that it converts low voltage power at high current into high voltage power at low current. So usually a step up transformer is used for industrial purpose. Now it is then at the consumer point stepped down in stages at the substation and distribution points to the voltage needed in the industrial applications, often 440 volts or more. This voltage is used for industrial purpose, and at domestic purpose it is used for 240 or 30 or even 220. In general, in our domestic supply, power is supplied at 220 volts from a step down transformer. So it is for domestic purpose, power is drawn at 240 or 220 to 120 volts. So you see here, this is the power plants, power station here. Here power is produced. You can say that 25,000 volts or less than 25,000 volts. But before supplying to this city or to the consumer points, this 25,000 volt has to be converted into higher and higher volt, say 7,50,000 volts, converted here and then supplied. And this 7,50,000 volts come to the here substation, that is called power grid, and this substation again converts this 7,50,000 volts into lower voltage by the application of the step down transformer, and then from here this power is supplied to this place, and here this power comes in the form of 11,000 volts, and then here again a transformer, a step down transformer is there, and this converts this 11,000 volts into domestic voltage supply, that is 20 volts or even 120 volts converted, and then it supplies. So thank you for today's, and next day we will take another class. In that class, I will show you the video clip. So for till then, just you have to recap all this, and this lecture will be uploaded to YouTube. So